Hello, my name is Antonio, and today I'll be talking about the heat treatment type of annealing, which is a process in which you increase the temperature of a metal and then you follow it up with very slow cooling rates. To be more specific, I'll be talking about carbon steels for this case. What we see is that there's different types of categories for annealing, and they each tend to affect the microstructure in a different way, which lead to certain mechanical properties. Overall, for each annealing process, what you tend to see is that the change in carbon concentration also affects at what temperature you wish to begin the annealing process. But for each one of these processes, you always want to go under the critical temperature of carbon steels, which is around 727 degrees Celsius. By doing this correctly, you get to see an increase in ductility, formability, and machinability, which are very helpful in terms of real-world applications. As we look at the iron phase diagram, we see the different categories of annealing. Process annealing tends to be used on cold work steels since it provides the occurrence of recovery and recrystallization in which there is stress relief and increase in ductility. This helps in the case that the steel needs to be cold worked further, but you wish to reduce the probability of cracking. Spheroidizing annealing is commonly used in hypereutectoid steels in order to increase their toughness while still having an increase in ductility. And this is done by changing the shape of the cementite that is present into spherical carbides. And in the case of full annealing, it's used mainly when one wishes to reach the phase equilibrium microstructures that are shown commonly for iron carbon steels, and all the while still maintaining the increase in ductility. We can look at the effects of annealing in terms of a pre-cold work steel, which is in image A. The dark spots are perlite and the white spots are ferrite. And when this steel undergoes process annealing, we can look at B, and it shows how the elongated ferrite grains from the cold work become strain-free grains. And in the case of C, with full annealing of A, we see the phase equilibrium microstructure. And since this is a hypoeutectoid steel, it contains coarse ferrite grains with no signs of cold work. And image D is of a hypereutectoid steel with higher carbon concentration that undergoes spheroidization, and we can see that the spherical shaped cementites are within a ferrite matrix.